And we were able to visualize data in all these new ways. And over the years, unfortunately, what's happened is, at one point they renamed the product and called it VisualWorks. And at the time it seemed apropos. But over the years, that's somewhat slipped a little bit. And so the title that's in the program is about binding open source graphics libraries or open source graphics stack with VisualWorks. And the alternate title is to basically do things we're doing to try and put the visual back in VisualWorks. So that's a bit about me and where I come from and the motivation. Some apologies. Usually when I come to a conference like this, I try to use the opportunity to drive me to do some new things and to have some new neat things to show. And I was really excited about that and had some neat ideas. But unfortunately, we're in the middle of VisualWorks 7.7 release, and that has sucked down a huge amount of time lately. And I had a wonderful experience with this little bugger right there. About a 6-week or 6-day thing, and then the kids got it, and so I haven't got as much done. And this has become more of me thinking about stuff as opposed to stuff I could show you. So a disclaimer, anything I show today, some of this stuff is, we are going somewhere with this in the product. Other stuff is me. It's, as Dan says, it's thoughts I've had while riding my bicycle and things I'd like to see happen and things I'm playing with. But it may never see the light of day. So there's no claim about whether it's something official or not. So the first of the 4 things I want to talk about today is CAIRO graphics. This is the most developed of the 4 things I'll talk about in VisualWorks today. But it's also the thing I've talked about the most. So I'm kind of weighing how much to spend on this versus some of the other stuff. CAIRO graphics is a 2D library. It's a 2D graphics library. It is the free desktop's answer to things like, help me out, the Windows API. Drawing a blank here. The way you draw things in 2D under Windows, and Quartz on OS X. Both Apple and Microsoft have these relatively strong modern 2D graphics libraries that do anti-aliasing and do alpha blending and all the things you'd expect in gradients, things you'd expect in a modern graphics API. And the Linux guys don't have anything, the X11 guys, and so they've come up with this thing called CAIRO. And the cool thing about the way they do things is they say, well, we won't just do it for our platform, we'll do it for all the platforms. So CAIRO is this library that wants to draw on Windows or on Mac OS X using the facilities there, or on X11. And then they go a bit farther and they say, why not? Let's draw to PDFs and PostScript and SVG. And let's do mobile phones. So it's a very portable library, and it's able to make all kinds of different outputs with it. So I was saying earlier, pictures are good. This is one of the neat things I think about Smalltalk, at least for some of us. Some of us like to sit and just model things, but for a lot of others, we like to explore or visualize data. This was one I did a little while back, an example of what happened when I went from I've never had alpha blending to visualize data, and now I have alpha blending. So this was I did some data, and this was actually something Andres was talking about, and I've heard others talk about, is what is the call speed of sending some of these external messages from Smalltalk. And one of the things that gets often tossed around is, it costs a lot to marshal the arguments that you pass with your arguments or that you don't. And so I thought, I'll test that. I'll make myself a little baseline function. It's a void, nothing being marshaled in either direction, and I'll time it, and then I'll time these other ones. And because I'm taking multiple samples, for each sample I get, I'll draw this little kind of 0.5% alpha patch, and then I'll just stack them all up, and that way I'll be able to see where they cluster, because the more they stack up, the bolder it'll get. And then I can also see the spread. So this was an example of something right away that I was able to start playing with and seeing the speed difference. And it's not as far as the actual test itself. It's the marshalling part of DLLCC calls is not usually the significant part. It's the overhead of making the call itself that tends to be the more significant part. So if you're playing with CAIRO, one of the things you do, this is kind of a rite of passage, is one of the very first things you do is you have to make a clock with it. I don't know why, but everybody who plays with CAIRO makes a clock. So let's see, I have a clock. If I do this, we'll see how well this works here. One or two other people have seen this before, so I apologize. So this was a clock we did where we wanted to play with it. And that's visible. So this was a clock where we decided to do things backwards. Traditionally, you have the little hand to be the biggest hand, and the biggest hand be the little hand. And we thought we'd turn it upside down. We thought we would make 3 clocks in one. We'd put the second clock and we would actually have it rotate relative to the minutes. And then the minute clock we would put relative to the hour and have that rotate around. It was kind of a fun clock. It's a non-standard way to view time. I'm going to get an error here, I think, which is expected. The funner one was when we actually sped it up. Not that time really goes this fast, but then this gave us a feeling of, ooh, pretty. And so we were able to make time go real fast. And we actually made a couple different clocks, but that was kind of a proof of concept that, okay, we were able to make this library and drive it well and do it on Windows and do it on X11 and do it on OS X. So, go back here. So the basic CAIRO model is you basically have a source image. I mean, the basic thing that gets done with all this stuff is you have some source, you have some mask, and then you have some target. And you basically squish them all together, and out comes some composited image. Everything you do in there, while it may not actually do that, it may not actually do the bit blip behind the scene, this is what is always being logically done, whether you're rastering to a PDF surface or a PostScript surface. And so that's kind of the way you think about everything. We did a presentation. The other thing you do if you're doing CAIRO shortly after you begin doing a binding for it is you have to you actually have to write a presentation in CAIRO. And so we did one of those. I just quickly fired up. Not my intent to actually go through it. This was done about a year or so. It was 2 years ago, but it was kind of our self-training thing. And so we wrote this presentation, and it actually used CAIRO to do all the rendering and everything. I'm trying to remember if it actually had any interesting, just clicking through it real quick to see if there was anything I wanted to make sure I hit in here. Talked about the different kind of surfaces that a CAIRO can have, how you set them up. So this was almost a tutorial level presentation about CAIRO and how you use the binding in VisualWorks for it. There were some interesting examples that were self-rendering where we showed some of the examples. Here's the Smalltalk balloon, and this was kind of a fun example because I consider this actually a self-rendering example. The code you see renders itself and then displays its very own source as part of its rendering loop. So that was a bit of fun, and the same here for... One of the neat things I've really enjoyed about CAIRO, though, is this whole path thing. How in traditional frameworks, you create these polylines or paths, and in CAIRO it's been kind of enlightening because you can have disjoint paths, and they're composed not only of linear segments but also of curved segments, and so you can put together this whole complex disjoint path and then just tell it stroke, and the whole scene will be filled in with one shot or fill, and you can do things with the direction of the path. If it goes backwards and you're using the path for a clip, you can actually get negative clip, where you can have a donut shape that's hollow in the middle and get a clip pattern that is not just a classical clip rectangle. And so, it was interesting to hear Andres Fortier talk about the transformations in OpenGL. Very similar concept here is how you can save stack. In fact, also kind of similarities with the stuff that Alex talked about with Worlds the other day, where you can come along and you can say, well, okay, I've got my drawing stack set up this way. Now I'd like to save that, and then I'd like to go make some more changes. For example, maybe translate to the middle and change the scale and do some rotation, do some drawing, and then when you drop back out of that block, you drop right back to the context you were at. And so this is very handy for kind of setting up intermediate states to draw things. Ooh, I want to draw this one in the middle. And it's been kind of an enlightening way to do drawing versus the old, kind of the old classic APIs. And you can group with that as well. So that was a dated presentation about CAIRO. So flip back here. So one of the things I get bad about is in the first days when we were doing CAIRO, I was doing a bunch of fun demos and blogging about it and putting up movies and stuff like that. And I don't do that as much anymore. And so I feel bad. I feel like I should have some new snazzy demo or something with it. But the fact is part of the reason is because I'm doing the boring grunt stuff, like getting the libraries to compile on all the platforms now. But other people have kind of taken that, and that's been kind of neat for me to see. These are just some of the people I know of who have pretty regular contact with me and showed me some of their applications. These guys from Stakepoint have built this entire project management system, and it's all using CAIRO. And not just for the gradients and the layouts, the project management, but he's redone all the widgets. He has kind of his own widget look and feel so that he doesn't use the classic VisualWorks one, which is a bit dated looking. The guys at Miriam Tech have done the same thing, but they've also taken the CAIRO libraries and ported it to Gemstone using, Ken Trice took the Alien FFI from Squeak, put that in Gemstone, and then took the CAIRO port from VisualWorks and used that, and then he uses it with his Seaside app to actually generate images and PDF files that go along with his app, and they have to do with golf courses. So he's got these complex layouts of golf courses, and he's doing all these fun graphics with that. KnowledgeScape guys have a bunch of stuff. Lamb Research, they've been doing a bunch of machine animation stuff that they're using with it. And the guys at Key Technology, where I used to work for, which is kind of what got me started, they use it for all their machine control vision stuff. So they're the ones doing the demos nowadays. So the status of this, as far as, kind of where are we with this? As I say, it's in preview in VisualWorks 7.7, which means we're kind of considering supporting it. We've figured out how to make it so it's kind of a turnkey part of VisualWorks now. You just take your OS X app, and it's all the libraries are there, and they're relocatable, and you can just use the library with your app and everything. And the same is true for the Windows. There's just one DLL. You just put that next to the VMM, and everything works. It's a wonderful community to work with. One of my most enjoyable part about it is I love the Smalltalk community, and I love the interaction I get with fellow Smalltalkers, but it's been nice to kind of reach out and to have some interchange with people from this other community. And it's been able to go both ways, and that's been neat. Not just them kind of teaching me a whole bunch of new graphic stuff, but a number of them have said, wow, that's amazing that you can take our really cool library and then you can just play with it in an inspector like that or in a workspace. And they're like, could you show me how to do that? Because that makes our stuff very easy to use. And so that's been a fun, a real neat opportunity. One of the things we've done in the CAIRO binding, this is a bit of philosophy aside, and this is kind of based on some of my years. One of the things I've noticed over the years, and this is not necessarily a bad thing, I say the Smalltalk framework trap. Invent a new model. This is what we do in Smalltalk. We program new models to explore things, and a lot of the presentations here this last couple days have been about that, and that's a good thing because that's how we teach. Often it's, we don't understand something until we program a framework up for it, and then we begin to really understand the problem space, and so that can be very educational. The flip side of that is if we're trying to produce usable software, we often end up with about 4 different frameworks for doing the exact same thing. And you have to go learn not only the underlying stuff, but the framework itself and how that's done. So one of the goals we had in the CAIRO framework was to not do that, was to keep the binding very thin and to keep all the terms exactly the same. and to not invent new terms and new models and new ways of looking at things. It was very important to us that if you were a Python CAIRO programmer and you saw some Smalltalk CAIRO code, that you would be able to recognize it pretty fast. And that if you were a Smalltalk CAIRO programmer, you could take the code you had and go to the mailing list and ask a question that looked very similar. And they've done a good job of having a pretty object-oriented structured library, so it's easy to map those structures to objects and keep the method names we kind of have a convention, but keep them all very similar. And that's been real valuable to be able to do that. So we wanted to be able to reuse existing knowledge and to reduce the distance. And this pervades the other things I'll talk about today as well. So anybody read Greek or Chinese? The first three characters are P-A-N in the Greek alphabet. It stands for Pang, and it means all. And the last one is either Chinese or Japanese. It's Japanese, and it's the Japanese character for go, which is language. And so this is another part of, moving on from CAIRO. Another part of the open source community is the whole text engine, is the whole font text rendering engines. And so they came up with this project called PANGO. And that's where it comes from, is basically all language, and that's what it means, and that's how they like to render it themselves. So when we change it, we see that this is PANGO. And I don't have near as much stuff to talk about. We haven't gotten near as much mileage out of this yet, but just some quotes here from the PANGO site. PANGO is a library for laying out rendering text. One of the things that drove us to look at this a lot was internationalization text. When you have a string that has some Japanese characters, some Cyrillic characters, and then some Western characters, and you want to display that all at once, and you don't want to go through all the characters and figure out all the encodings and find all the different fonts and everything like that. PANGO, the thing they claimed was it just worked. And for the most part, I found that to be true. As long as you've got fonts, you can give it these big mixed strings and it will just do its job. And from making applications that have to go in international places, that was a huge win for some of the stuff we were looking at. And they want to work with CAIRO. There's very much a sibling relationship between these two. They're done a little bit differently. The PANGO library uses some of the GNU toolkit support stuff, such as the glib object stuff. But it's a bit more complex problem they're dealing with. And what was the other one here? The ability to deal with, various script modes, writing backwards, writing up and down, Hebrew, Farsi, all these different ways of writing text was something that we were also interested in making available in VisualWorks and not being stuck with the old left to right model. So when they say a wide variety in there, here's just some screenshot examples of things they do. Here's some Farsi text where it writes backwards. Badad, the guy who does this, has put these together. Here's another one that shows mixed characters of Japanese and English, where they're going both with various layout modes. Because in Japanese, sometimes you want to print the Roman characters rotated, and sometimes you don't, and they're able to support that. And this is actually one. I've done a couple of these myself, but this is from Firefox, this bottom one, where it's showing the fact that they're using PANGO to do the math-ML type rendering, and they're able to do all this math types rendering with it. So the part we have in Smalltalk right now is this object called a layout, and that's the high-level PANGO thing. And it's basically the old Blue Book paragraph. It's a chunk of text with some returns, and it's your paragraph. Or in VisualWorks, it's a composed text. Or I think in Squeak, it's a text morph. And it's your basic unit of text. And you can create these in VisualWorks. They're pretty easy to do. You throw characters at it in UTF-8, and then you can make things bold and italic and change the colors at various points in the string. You can set the font and get that kind of stuff. And you can measure all kinds of stuff, left, right, set the alignment, that kind of thing. And then, of course, when you're done with it, you can either display it or you can path it. And the pathing thing is kind of nice in CAIRO. What that means we can do is, rather than rendering it, we can tell it, well, we'd like to make a path from the outline of the text. And I don't know if you noticed when I did when I was showing the old CAIRO presentation, all the characters were outlined in a stroke, and this is like an outline stroke. And we did that by pathing. We were simply able to say, okay, path the characters, now stroke the outline of the characters, and then it just works. And so you can, once you have these paths, you can take the paths and munge them and reshape them and twist them and perform arbitrary math on them to get all kinds of interesting things. As far as PANGO status in VisualWorks, this is kind of the next one after CAIRO. that I'm chasing. The library is about half bound right now. And like I said, the layout counterpart, we have all that in Smalltalk. We're able to do that pretty easy, and we've used that quite a bit. What we haven't done yet is we haven't made the real objects for emphases. We'd like to have Smalltalk counterparts for those bold, italic stuff. Right now we're just using the APIs that CAIRO provides. And we'd like to build a text editor out of it. Now luckily here, and the reason is that this really stresses our ability to measure interline distances and have a nice fancy new text editor that does fractional character measuring and all that kind of good stuff. Michael Lucas Smith is just finishing a Canvas-based editor for the web velocity stuff. And it's in JavaScript, but he and I have talked about actually porting that back to Smalltalk, since it's done pretty clean, pretty simple, and then using PANGO for the rendering engine. We're kind of excited about that. I may come back to these demos. These are just some things, some VisualWorks add-ons that I've done that are extra little tools that show kind of some of the fun stuff you can do inside the image. So the final thing we're struggling with here with this CAIRO PANGO stuff is what to do about the old graybeards, where the old graybeards represent the old 2.4 Penguin guys, the Solaris guys, and the AIX. These are platforms that we support on VisualWorks, and so this creates a bit of an interesting problem for us, where the free desktop guys are pressing PANGO and CAIRO is all on new Linux stuff. And that's great for the new Linux guys. You'll find the binaries are always there installed in any Debian install or anything. Making it work on Windows and OS X is something doable. If you beat the make files long enough, they will make. But the bigger problem is some of these older platforms that have very old font config engines and things like that. And that's something, that there is no answer for it right now, but that's a question that we're dealing with about how do we support our legacy systems and yet at the same time go forward with some of this more modern graphic stack stuff. So switching gears a little bit, yet staying on this graphic thing, here's an old problem. Many years ago, they told programmers, we'd like you to put, this is great, we appreciate the ping pong game, but we'd like you to put some text on the screen. The programmers ran away and they said, no problem. And they made some text. And they said, ooh, pretty. And then they said, now make it bigger. And they said, no problem. And it didn't look so good because all they did was multiply it. And this is the classic problem, the old bitmap font problem. And they came up with all kinds of interesting schemes to get around this, but at some point Apple and some folks decided, oh, let's make this thing called TrueType, which also eventually became FreeType and OpenType. And so we got scalable fonts as a result of that, and just-in-time evaluators that take font languages and make them bigger. And of course, this allowed us to make nice, pretty fonts very big. But one of the things that was always interesting, that's always been interesting to me, is what about the icons? What happened to the icons in that? Kind of the same thing. Make me a hand icon. They did. They said, make it bigger. And they did. They said, that doesn't look so good. And nobody cared. And there's been, you kind of have the intermediate solution with these things called, on Windows you have the ICO files, and on OS X you have the ICNS files, I think. And basically the solution there is take the same icon and render it lots of times at different sizes, and then we'll interpolate between them. Which was kind of where the font guys tried, with they would basically give you a bunch of different size scalable or different size bitmap fonts, and then you were supposed to somehow scale in between and have it look pretty. And the problem here is, of course, if you don't give enough samples, it doesn't look good. If you want to go way beyond the size of the biggest sample, again, you get the pixelation problem. So one of the things we're looking at, one of the things that's real interesting to us, is this thing called SVG, or Scalable Vector Graphics. Now, SVG is brought to you by the W3C, same people that brought you the internet, along with Al Gore. And as everything the W3C does, it's always over-engineered as usual. It's kind of this spec that solves some problems well, and then seems to have this other stuff in there, such as animation support and things like that. We haven't been really interested in that. We're interested in the scalable vector graphics problem and really nothing else. And there's been a trend towards this. The Opera web browser, all of its icons are now in SVG. They don't play this game with different size bitmaps. And you see KDE and GNOME are beginning to do the same things in some of their software. And so it's a lot of mobile devices are really doing a lot more with SVG. And in the new VisualWorks 7.7, we have a new icon set. We've redone a significant part of the icons, and a lot of those we have in SVG format. And having them in SVG format has been real valuable. It's very easy to reuse. For example, you can bring up an editor and pull a couple parts of a icon graphic and put them in another one, and you can reuse, if you have an hourglass as part of an annotation in your icon, it's very nice in SVG. If you're using GIMP, it's much more difficult to cut that out and get the aliasing and put it over on the editor icon. And then you can resize it if you want your toolbars to be 32 instead of 24. The SVGs make that very nice and very easy. And so that's kind of our motivation for that. I don't have any demos to show with SVG right now. This is where I really wanted to get at this conference, and this is the area that slipped the most. But basically what we've done is we have it's a tree-based structure model. We have SVG node object, and then all kinds of subclasses for all the different kinds of element types. And we're able to parse the entire test suite now and turn that, and so that's a good milestone we've reached. And able to parse all the VisualWorks icons as well. And that's been good as well, because found that as we began playing with SVG that like any XML spec, it's kind of, everybody does it slightly differently. And so you can pass the test suite, and then everything we had from Inkscape, which is where we get most of our drawings, we found that all of it was different and was doing things in non-standard ways. And so, being able to do all the VisualWorks ones has been nice as well. And so the first thing we want to be able to do is render them. And we use CAIRO to do that, and PANGO to do the text, and we use visitor pattern. I hope Alex isn't here. Apparently, one thing I've learned at this conference is that patterns are suspect, and so I've now got to find a different way to enumerate my SVG nodes. And so I'm not sure exactly how to enumerate the tree structure in a different way, but maybe Alex will give me a good way to do that. And we're able to render a bunch of, maybe not all. I know of a couple that we can't do quite because I don't have the masking quite right. But we're able to do a lot of the icons in there. We can render them at different, any arbitrary size we want. About half of the SVG tests, but the SVG tests don't look very complex, and so I can do about half those. So I'm plugging away at that. That's kind of where we're going. Is it just for icons? If that's the only problem it solves, that's good. That's a good thing to have support for that. When we did the VisualWorks icon set, we had somebody else do that for us. I did not draw them. I helped work on them a little bit, but being able to use a format that is a familiar format, such as you get from Draw Freely or what's the Adobe one, Freehand, or any one of these, and basically being able to have a graphics artist do that work for you, and then work with the art he gives you is very nice. But one of the things that's been interesting is there's this growing interest in using SVG for UI construction. And it's kind of an interesting thing because SVG has support in there for animation and stuff, but people are kind of ignoring that and coming up with their own engines because they want to do richer UIs than just, this moves along the path. And so you've got these guys, here's a couple of the projects. The Qt guys are even kind of supporting some linkage with SVG things where they make actually active widgets out of them. These are a couple different projects people are playing with them. I'm going to back up for a minute. There's a quick... Yeah, we got time. So one of the things that's kind of been interesting to me is this guy named Andre Schmidt in... I don't want that. I want this one. In Germany has been playing with this thing called Sims UI. I don't even think I put that one on there. But he basically does this thing. This is a screencast he did where he basically takes and uses Inkscape to draw this SVG thing, and then he has this engine, which it's a Python engine, but he basically then links, he begins basically making an interactive widget based on what he's drawing here. And this is very nice. This is kind of almost going where the web has gone, where you have the programmers do just the basic stuff, and then you're able to hand it off to a graphics artist, somebody who can really make things look pretty and make them look polished, and kind of get that synergy there. Instead of, Smalltalk programmers love to make interesting UIs, I've learned over the years, because we're all about function and not so much about pretty and eye candy. And so it's nice to be able to allow one of these guys to work in a graphic editor environment that they're familiar with. And where's Andre at this point? think he's taking, so he takes and he basically takes and edits the XML. This is where he puts the hooks that allows it to hook into his engine. And I wasn't watching. Did he make it slider yet? Did he do the slider thing? So there we go. This brings up his engine, and he's basically drawn a simple slider. And he now has a slider model, and he's able to do that, and it's pretty primitive. But then the nice thing is, and that's where most small talkers would stop, or they would use morph and kind of place things, make it look ugly or whatever. He goes on, and you don't have to sit here, and this isn't an Inkscape tutorial. But he goes on, and he, there we go. So near the end of it, he's actually glossed this thing up, and all just by drawing, and he's got this nice UI. So I'm kind of interested. Like I say, this is the Travis riding on his bike thing. I'm interested in what can go here. I see these projects keep coming up. I see them keep struggling, and I don't know if the reason they're struggling is because it's a bad idea, or because they don't have a good enough language to pull it off. And I'm interested in finding out which of those two that is. We'll see what happens with that in the coming while. So, close that. So back to play here. So the last thing I want to talk about a little bit here today, maybe we'll do some demos and questions after that, is if only Michael was here. This is Michael Lucas Smith, a colleague of mine at Cincom, and some of you may have seen his name around. He would give this following part of the presentation. This is Michael and I support each other a lot in this kind of stuff, and he helps me out a lot with the CAIRO PANGO stuff by testing it and being someone to bounce off of, and the roles reversed in this case. He's the one driving this. Michael really wants to make, and this is part of maybe why we just have different games, or different goals. Michael really wants to build a first-class 3D game in Smalltalk. This is like his ultimate goal in life, is to produce Doom or something like that. And he wants the full thing, not just kind of simple things. He wants the light shading and the ripples on the water and the 3D sound. And he's really hooked on this, and I think it's great. It's been fun to watch him chase this. So if he were here, he'd do this. So Michael's been playing a lot with OpenGL 3.0. And it's been very interesting to listen to Andres Fortier's talk today because of the direction he's taking OpenGL and with MiniGL and what he's learning and playing with it. I discovered as I played with this, kind of as Michael's guinea pig, one of them. OpenGL has got to be the most abused spec name in history. In some ways, it's a lot like, as I was thinking, it's a lot like Smalltalk 72, 76, 80. They're all similar languages, but they're really not alike. You can't load a Smalltalk 72 program in Smalltalk 80 and have it work. They all have a similar name, but they're done very differently. And OpenGL has morphed a lot since its original inception to where they're at today and what they're pushing today. If you look at the OpenGL 3.1 spec, which is kind of the 3.0 spec plus just a couple things, but really what it is, okay, here's what we're going to admit. Here's all the things that we want to get rid of and move out of. And, they're getting rid of all the manipulation of a 3D frame and the frustum. They want you to do that yourself. There is no client-side state. There is no library state you keep anymore. The glut is something of the past, and they're not doing that. Where they're really putting all their focus is on these shaders, these little programs written in this stripped down C language that you put on that you can put on your card, and it basically compiles it at runtime and then does things with it. And so they've done a very simple pipeline that does that. This is one of the things Michael's done. Is this is one of the interesting things he's run into is as you go out there to find out about how to use OpenGL, since there's the net has accumulated about 10, 15 years of how to do this. You never really know how you're learning how to do it. Are you learning how to do it the 1985 way, or the 1992 way, or the 2010 way, or whatever? It's kind of like just have if we had posted Smalltalk 72, 76, and 80 to the internet all this time, and then somebody came along and tried to figure that out, they'd have the same problem. What kind of Smalltalk is this? And so he's been putting together these lessons to try and cover that. Let me I'll just show you a couple of them, and they're a work in progress. So he has these lessons in here. And these are part of VisualWorks 7.7. You can load that you can load it there and contribute it, and you can load them up and play with them. And he basically takes you through this lesson stuff. Why is this so small? Is that showing up there? Yeah. And all of these have, in a comment and what's the first one? He kind of starts small and works you up, and so you can work good. So he starts with the classical multicolored triangle somewhere in here, and he has some different things. What were some of the interesting ones? And I went through all these, and it took me about maybe close to a day to go through them. And you've got all the code in here, and he writes a big comment for each one, and which methods to look at, which ones are kind of supporting message, and they build on each other. Shows you how to set up the camera models. He's got support in there for doing the camera model and the perspective model, and getting that set up. He kind of takes some segues. Here's one where he does the new thing about using your graphics card to do a bunch of numeric computation. Actually, don't even draw anything, just do a bunch of number crunching. He done some stuff with that. Where it really started to get kind of fun for me as I played with this was in this the animations thing, where he basically gives you a little way of doing viewing. And so now I have this pyramid, and I can spin it around. Nothing that hasn't been done for 20 years with OpenGL, but this is all. The nice thing about this was I could see the code, and this was all done doing the modern way, supposedly. Michael spent a lot of time on various IRC channels and stuff saying, okay, so what's the old way, what's the new way, what's the right way, and filtering through all that. Does textures was one of the ones I really liked, because this gave me an idea for what I wanted to do. I don't know if is that legible? This is a great classic. It's just a cube. It's got the same cartoon about goofing off while we wait for compiling. He did some stuff. He shows how to integrate it with CAIRO in here. How to do multi-textures, frames. Particles 2 is kind of fun. Let's do about 5,000. So here's a bunch of swarm of particles where he's showing, basically lots of different geometries and how you're dealing with those. So this was neat, because I could go through here, and one of the things he does, he just simply puts the I don't want that one. Let's show texture maybe. No. Shaders. He just puts these shaders right here, and so you can actually see that these various fragments of C code that get downloaded onto the board and compiled and used there. And this was neat. You spend a bunch of time in the 3.1 in the shader language spec, because that's really where OpenGL guys are pushing. Does that mean it's almost time? Hey, that's what my timer says too. Thank you. So let me drop back to. So, like I say, those are a work in progress. He's playing with them. He's getting feedback from people as they're doing stuff, and reworking some of them, moving some stuff up, moving stuff down. The idea of being able to quickly educate people how to play with it. For me, it was pretty successful. What did I learn, from doing it? As far as the simple model with the new 3.0 STO is you make points in data. You hand that in a big memory buffer to the card. You define some global data. And then you have these shaders, and the shaders were the fascinating part, because in my mind I saw this pattern. Basically, they reminded me like collect blocks in Smalltalk. I write the guts of the collect block in something other than Smalltalk. It's this little C language, but it's basically for each point. I basically write this little fragment for the vertex shader that is for each point do this thing, and you can pass data onto the next block. And you can have just one vertex shader, or you can have lots of them. That's for each point in the geometry, and it takes care of filtering out the points that aren't visible or not. And then after that, you turn around and do these fragment shader thingies, and that's for each pixel. And it's very simple as, where is this at? What's the normal? Make this color. And once I began thinking in this classical Smalltalk collect type approach to things, for me it made things really very open. One of the things I did. One of the things I was able to do pretty quick was I took my, kind of the classical okay, prove to yourself you're learning something by taking what you've seen there now and where did I put it? Do your own thing with it, morph it to prove to yourself that you learned something. So one of the first ones I did, I wanted to do this one here. So this was an Earth picture that I wanted to make. This is somewhat standard, kind of a standard class thing. The thing I was interested in was making a glassy effect to it. So if you pay attention closely as I'm rotating it, you can actually see that it's a see-through Earth. And so you can see the continents off the backside. Most visible if you come up top to, or down below to Antarctica and rotate it. I can see the Antarctic shelf up, or the Arctic shelf up below it on the other side. And there's Buenos Aires right there. I think up on the edge. We're just peeking around the edge so I can get to it. Anyway, so that was fun to play with. And after that, it was like, what if the whole world, in the Smalltalk world, we often think of this world domination thing, where we'd like to take over the world. And of course, the balloon is our logo. And so, what if I made a balloon? Could I make a balloon out of Smalltalk? And could I do the classic Smalltalk balloon and then use the texturing to put the Earth around it? And this was kind of fun to figure out the geometry. It turns out there's a whole website dedicated to how you do heart curves, which is what I used here. I used a warped heart curve to come up with the balloon. And I didn't know that people sat around and worried about the cotan functions for how you define heart shapes. I was amused and thankful for that part. So, coming back here. So, as far as where Michael's going with OpenGL to do, he's doing some more lessons. Two of the things we're disappointed, frustrated with is how we keep this thin, how we keep it so you can program shader language type stuff in Smalltalk. But the current way of just passing a string is kind of tricky, and you lose if you have a variable name. We'd like some more linkage there, so we're looking to move that bar a little bit, not too much, and to just get some more interaction so that the tools, the Smalltalk tools, to help you there. The other thing is when the shaders tank currently, if you have a shader that's a bad shader, you hang VisualWorks. It just, this process was a save very often type process right now. And so we need to get in under the hood and figure out why we're tanking so easy, and at least make it so if you tank, it behaves friendly and doesn't die. And some things with the GL receiver, the way he did the binding. So I'm at 42 minutes. Questions? No, not yet. That's what I was saying. That's an area we'd like to improve because I don't have a hint yet. I'm hoping. Michael's response to me was, "Why don't you help me work on that?" So that's something we hope to work on, I guess, and how to make that better, because it's a pain. When the shaders we did here are all very simple. They're 10 lines at most, and when you declare your variables, your uniforms, basically your variables that are passed in, if you have a typo in one of those, bam. And that was very frustrating. It's like, oh crap, save again. Literally, I was about ready to go write a process that saved my image every 10 seconds just because I was tired of hitting the save button. Other questions? So that's a great question, and this is where we get back into the unclassified part of the response. If it were me, yes, I just rewrite the whole thing in CAIRO. I like CAIRO, and I would love to just gut the whole thing and rewrite it. I'm not interested in maintaining all these different cross-platform things. Is that the reality of what's really going to happen, and does everybody agree with me? Not as much. So that's, I think, the part. The part of the roadmap that is interesting at this point is not the technical part, but more the political and the backwards compatibility issues. You take all these customers. So one of the things that there's been a couple of people who have tried this idea of, well, can I take the VisualWorks API, the graphics context API, and basically refocus it on a CAIRO backend? And that turns out to be, like most of these things, easy to prove to yourself is possible very quickly. And then you spend the next months trying to fix all the edge cases. And it's not to say it's not doable. It's just that's been kind of the interesting thing. The current one that probably shows the most promise is the guys at Hague have done a layer where you can basically make VisualWorks use CAIRO for all of its drawing on Windows or OS X. And it mostly works, so that they're getting there. And so, does it solve the flickering problem? Not always. So often those problems have nothing to do with your graphics layer. They have to do with how you're interfacing with the graphics layer, some assumptions you made that are bad. And drawing with CAIRO, while you can make it, the VisualWorks APIs do it, is different. It's more of a transaction-based model. You set up lots of stuff and then say go. And that's a bit different than the classic, graphics context, draw this thing, this immediate mode drawing that we're used to in VisualWorks. Any other questions? Oh, right there. To make sure I understand the question, you've played with CAIRO and saved some graphics. You've created some surfaces, saved some ping files, and then you save VisualWorks and restart it, and there's issues. Because, of course, it's an external library. The same as if you'd drawn a pix map in VisualWorks, and it's something maintained by the OS. So then I'm curious. I understand that part of the problem. What is the question? Is how do we get around that, or? Well, how do I solve this problem? I guess I haven't had to actually have a surface exist across across snapshots yet, as far as retain in memory. One of the ways we solve that problem now is we support drawing on VisualWorks images. So you can take a VisualWorks image object and make it an object that CAIRO can see, but all the bytes are maintained in VisualWorks. And that's been very nice, because the classic problem with VisualWorks is you can draw on pix maps and you can manipulate pixels in images, but you can't do both without converting back and forth. And so using CAIRO on images has allowed us to draw on images, and it in some ways solves that problem right there. Basically, you can tell CAIRO, I'm going to manage the bytes. There's an API in the library for saying, well, I want to make an image, but I've got the byte array, so don't worry about it. And in that case, it should work from a snapshot. You might have to recreate the handle, but it's certainly doable. Does that answer? Okay.